Hey, curious kids, Kevin here. Today on A Place Called Space, we are going to learn about stars. I got my big inflatable sun here to help me out. Stars on my t-shirt, stars back here. There are stars everywhere, and we're going to learn all about them. What are they made out of? How many are there? What are the different types of stars? And what happens when a star dies? Can stars die? Is our sun going to die? When is it going to die? Are we going to be okay? So I'm going to tell you all about that today. So we got to start with the star that we all know. What is that thing in the sky? What do we call it? The thing that gives us so much light, all this brightness coming in. What is it? It's the sun, right? So the closest star to us is the sun. It is the only thing in our solar system that's a star. So, got something in my eye. Got starlight coming in. We have one star in our solar system. Each solar system has one star. It could have more, and I'll tell you about that later. So closest one to us, 93 million miles away, or 150 kilometers. So ideal in kilometers. I like to use that because the rest of the world does, and it's easier to get along with everyone. And the distance from Earth, where's my Earth? Got planets everywhere. The distance from Earth to the sun is 150 million kilometers, or 93 million miles, and we call that one astronomical unit, AU for short, and that's how we measure very large distances in space. Well, we can measure even bigger distances with light years, but when we're talking on the order of our solar system, we talk about one AU, an astronomical unit, that's 93 million miles, or 150 million kilometers. But okay, this is just one star. Let's learn about more stars, bigger stars, further away stars. We got one in our solar system, but how many do we have in our galaxy? What's the name of our galaxy? Shout it out. The Milky Way galaxy. That's right. Now, officially, its name is just Milky Way. They don't add galaxy to the end of it. We just call it Milky Way officially. But how many are there? Are there thousands, hundreds, millions? There's even more. There are billions upon billions of stars in the Milky Way galaxy. Now, we don't know exactly how many there are because there's so many to count. We take a look at the part of the sky and we count up all the stars we can in that area, and then we multiply it around to get us a whole picture of the sky. So we have a range of stars, and it's somewhere between 100 billion to 400 billion stars. That's a bunch of stars. How big is 100 billion or 400 billion? How many zeros do they have? Wrote it down. This is 100 billion. So if we look at it partly, it's 100, 100,000, 100 million, 100 billion, and 400 billion. So somewhere in between here. Now that is a lot of stars. That's got to be more stars than anything we have here on Earth. Maybe, but maybe not. We actually have more of these. More trees on Earth than there are stars in the Milky Way galaxy. What? Is your mind just blown? How can we have more trees than stars in our galaxy? So this is a plant. It's a nice prop for a tree, right? You know, it works. That's the trunk and the leaves. Well, how many trees are there? So there's got to be more than 400 billion trees. 3 trillion. The scientists and researchers who counted this up and figured it out were baffled and rechecked their numbers over and over again to make sure they were counting it right. So let's do this together. So we got 3, 3,000, 3 million, 3 billion, 3 trillion trees. So you see there's more zeros for trees than there are for stars in the Milky Way galaxy. We got more zeros over here. One more zero. That's crazy. Now, 3 million trees. All right, that's got to be a lot, right? It is more. There are more trees on Earth than there are cells in our brains. So if I pulled up my brain, held it in front of you, And then we were able to count up all of the cells, the tiny little things that make up us and our skin and our brain. There would be more trees than cells in our brain. There's so many trees, but we need more because we have climate change. We're pumping a bunch of bad stuff into the atmosphere, and the trees help take out some of the carbon and then release oxygen. So we take in oxygen, breathe out carbon dioxide. Trees will take in that carbon dioxide and then breathe out oxygen. So we've got 3 trillion trees, but we need even more to help make our planet healthier, to help the environment be better than it already is. So keep planting trees. We still need more. Still need more. Okay. We've learned 1 star in the solar system, 100 billion to 400 billion stars in our galaxy. What about everything? The observable universe. Spoiler alert. So it's on my t-shirt here. So this shirt says that there are 10 to the 22. That's how we say this. It's a way to write big numbers in math. 10 to the 22. And then it says here, stars in the known universe. So known universe is because we can only see so far. It takes time for light to travel. So our sun, which is 1 AU, 150 million kilometers away, it takes 8 minutes for the sunlight to travel all the way to us here on Earth. So when we're looking at really far distant stars, that light has to travel all that way, and it takes some time. So the furthest that we can see right now is 14 billion light years away. So if we go 14 billion light years there, all around, we get 10 to the 22 stars. What's that look like? How many zeros is it? I wrote it out again. I had to write them so small so they could fit. So many zeros. Let's count them up. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 zeros after that 1 to give us how many stars are in the known universe. Now that's a lot of stars. There are more stars in the known universe than there are grains of sand on all of Earth's beaches. Yes, if you took all of the sand on all of Earth's beaches, you still wouldn't have enough grains of sand to be more than the number of stars there are in our known universe. That is one of the coolest things I like to share with people because it's like there's a lot of sand. Like, look at these. Look how many sand grains are in there. And you're telling me this isn't even close to how many stars there are in the whole universe? No way. Yeah. So many stars. So many stars. There's got to be different types of stars, maybe different categories. But like, how are stars made? What are they made out of? So stars are like big balls of hot gas that are exploding. It's like fire, right? Fire. So it's bright and that's what gives us our heat, light for photosynthesis. The plants, they take in the light and they use it for their food in their bellies, and then that's how they live. Gives us light, fire, heat. So what are they? Well, they're made up of a bunch of different things, but mostly they are hydrogen and helium. So they are 3/4 hydrogen, so about 75% hydrogen, and then about 1/4, about 25% helium. You add those together, we get 1 star. Kevin, what is hydrogen? I'm glad you asked. So have you heard of this stuff right here? Water. Sometimes people call it H2O. That H stands for hydrogen. The 2 says that there are 2 hydrogens, and the O is oxygen. We've all heard that. Oxygen is it's what we breathe, along with some other stuff. So water is made up of hydrogen, and oxygen. If you just use one of those hydrogens, boom, it's the most abundant thing. Abundant meaning it has the most. It is the thing we find the most in our entire universe is hydrogen, because obviously our stars are made up of most of them. Now helium. What's helium? Have you ever gotten a balloon? Not one you blow up yourself, but one that you can hold with a string and it floats? Inside there is helium. It's lighter than air, which is why it can float. Less dense, meaning the particles are bouncing all around and they're really happy, so they're like up. That's helium. It also is something that only if you have your parents' permission and you do this with a supervised adult, you can actually breathe in helium, and then your voice gets really high and squeaky. I don't have any helium, otherwise I would show you how it's done. Helium was first discovered on the sun. This guy right here. So one of the mythical names for the sun is Helios, and that's why we named it helium. It is the first place we found helium because it's a lot more present. We can easily find it on the sun than here on Earth. It's harder to find helium here than it is on the sun. So it took us a while. So the first place we found it was on the sun. So we named it helium after Helios. So hydrogen, helium, boom, one star. Now, why are they burning so bright? Well, let me bring this back up. So the hydrogen burns into helium as you go into the center of the sun. So it starts as like hydrogen and then it falls into the center of the sun and it burns up into helium. All right, that's why it's so bright. That's what it's burning. It's the hydrogen into helium. Now, what are stars? Like, how do we make them? Well, it's a bunch of dust. I don't want to throw dust around because then I'd have to clean up my office here. But it's dust, clouds of dust. You might seen some pretty pictures that look like just colorful dust all around. We call those nebula. And sometimes we call them star nurseries. Have you heard of a nursery? It's where all the babies are, right? In the hospital, the coochie-coo babies. Well, a star nursery is a place where the stars can form. They can be born and they can build and grow. The nurseries take care of the babies, baby stars. So you got all of this dust floating around, maybe from the beginning of the universe when there's a big bang, some of it starts coming together, and then it starts turning itself into like a ball, right? And as you come together, there's gravity. That's the thing that if I jump up, I come back down, it's what holds us down. So the more things you have, the more dust, the more gravity, it starts coming together, and then it starts getting warm. Why does it get warm? Things come together, they touch. Help me out here. Take your hand, go like this, put them together, go like that. What do you feel? You can feel it starting to get warm, right? Yeah, because when things come together, they start touching, there's friction, they start to get warm, there's gravity, and then if you get enough of that, it starts in this little baby star that we call a protostar. Protostar, just a little baby star as it's getting there. Now, they can grow up to be bigger stars, or they might not work. So it's called if it doesn't work, we call it a failed star. So I've written down all of the names of the types of stars that there are. Well, not all of them, because there's so many, but these are general categories of when we find a star, where do we bin it? Where do we put it in its little category? What type is it? So we have a brown dwarf here. The brown dwarf star is the star that's a failed star. Means it didn't work. There wasn't enough friction. There wasn't enough all that dust coming together. So it didn't grow up to be a big old star. Next, we have a red dwarf star. So these are the smallest stars. After that, yellow dwarf star. I bet you know a yellow dwarf star. That would be our sun. Our sun is a yellow dwarf star. It's a little bit bigger than the red dwarfs. It's not that big compared to the other things that are out there. But that's ours. Now what's next? We got a white star. These are really, really bright stars. Red giants, even bigger stars. You might have heard of this one, or one of them. The most known red giant star is Betelgeuse. Betelgeuse, Betelgeuse, Betelgeuse. You can't say Beetlejuice 3 times in a row. It's from a Halloween movie. Otherwise, a guy named Beetlejuice will appear. It's from an older movie. If your parents are watching, they might know it. If you're old enough, maybe you can ask them if you can watch it this Halloween. But Betelgeuse is the most known red giant star. Next, we have white dwarfs. A white dwarf star is a burnt out star. It not failed, but it got really big and then it got smaller because it burned out. then turn into a white dwarf. A blue giant star is a big star that's super bright, but it's short-lived. It's got a very short lifespan. So compared to all these other stars that are around for like billions and billions of years, this one's only like a couple billion or a few 100 million years, and then it goes away. So they're hard to find. Then we have neutron stars. These are super dense stars that are spinning really, really fast. So dense, what does density mean? So it's what causes things to sink, like in water. Like if you throw metal into water, it sinks, right? Yeah, because the metal is more dense. It's got more things packed together than the water, so it goes down, which means it has more mass. It weighs more. So the neutron stars, being more dense, have more stuff packed in them. They're spinning super fast. Next is a pulsar. You see that? Pulsar. So that is when a star gets like bigger and smaller, bigger and smaller. Now, it doesn't actually grow that big and small, but when we're looking at them, like with the telescope, we're like, hey, what's going on? That star is like, it's pulsing. It's getting bigger and smaller. There's like jets of particles shooting up from the star, and they form around it. So as the star rotates, we sometimes see the big jets coming out, and then sometimes we don't. Sometimes we see the big ones, and sometimes we don't. Those are called pulsars. Now, lastly, binary stars. Now, I talked about this earlier, that you can have more than one star in your solar system. Binary, bi means two, so binary stars means there are two stars in the solar system, or two stars that are orbiting each other. So that means if we were here on Earth, we would see two suns in the sky. See this right here? This is an exoplanet. So those are those planets that are outside of our solar system, called Kepler-16b, and it has two stars. Those stars are orbiting each other, and then the planets orbit around those stars. So here's an example. They do exist. Now, are you Star Wars fans? Anybody out there like the movie Star Wars? Tatooine has two suns. It can happen. It can be real. This is like the real life Tatooine, Kepler-16b. How cool is that? Star Wars is real. Parts of it, some of it. We still don't have the Millennium Falcon. We're still working on building this one so we can go light speed and fly through the stars and visit other worlds and solar systems. So those are the main types of stars we have. Bring it up one more time. Brown dwarf, failed star. Red dwarf, smallest stars. Yellow dwarf, our sun. White stars, really bright. Red giants, Betelgeuse. White dwarfs, burnt out stars. Blue giants, short-lived, big and bright stars. Neutron stars, dense, fast. Pulsars, bigger, smaller when you look at them. And then binary stars, two stars orbiting each other. Whew, that's a lot of stars, a lot of different types. Now, what happens like at the end of the life of a star? Like you said, the white dwarfs are when stars burn out, right? Well, what happens when they burn out? Well, there's two things that can happen. If your star is big enough, it's super massive, there's an amount of bigness that you have to have. And if you're over this, you will grow big a little bit at the end, and then you'll blow up into a supernova. It's when a star explodes. Have you ever heard of that word, supernova? So the star explodes, and then everything comes back together, and it collapses on itself, and it forms a black hole. A black hole, and it just sucks everything in. What's a black hole? Nothing can escape it. It all just falls in. Wait, we have a star. We have the sun. Is that gonna turn into a black hole? Our sun is not big enough to go supernova and then turn into a black hole. Whew. So we're safe. Don't worry about it. We're not going to turn into a black hole at the center of our solar system. But what will happen? Well, eventually, our sun, when it burns out, it'll actually start to expand and get bigger and bigger and bigger, and then get a little bit smaller, and then kind of like turn itself into like a little bit of a nebula. So it will explode a little bit, but not like huge explosion and turn into a black hole. But when's that going to happen? We got a while. So our sun is approximately 4.5 billion years old, and it's only halfway through its life. So it has another 4.5 billion years before that happens and it burns out. So don't worry, we're not going to be around here for it. We got 4.5 billion years, to get away from this star and Earth and go and find a new place to live that is away from the star. That's a long time, 4.5 billion years. We've got a long time. It's okay. All right, so we learned that there's one star, the sun, at the center of our solar system. There's 100 to 400 billion stars in our Milky Way. There are more stars in the entire observable universe, the known universe, than there are grains of sand on the beaches of Earth. Stars are these balls of gas that form when clouds of dust come together. They start creating the friction to make yourself a star, right? And then they can not work and be a brown dwarf, or they can grow up and work and become like a red dwarf, yellow dwarf, maybe giant stars. And then at the end, some stars will kind of just burn out and fither away. Others will blow up in huge explosions and then turn into black holes. But our sun isn't going to do that. We got a long time before our sun falls apart. So make sure you click the thumbs up if you like this video. Hopefully you did and you'll learn some cool stuff about stars. There's a button down here. It's red. It's got white stuff in it too. It says subscribe. Click that button so you can be alerted when we got new videos, new lives coming to you every single weekday during while schools are closed with this COVID-19 crisis going on, 9 a.m. Pacific time, or as my Central friends like to say, Kevin at 11. So Kevin at 11 is here to teach you about space every day. Now I'm going to check out some of the questions. I've been seeing them over here, so I want to answer some for you. Do you know the names of all the stars? Nope, impossible. With 10 to the 22 stars? No. The ones I can tell you off the top of my head are the Sun, Proxima Centauri, Alpha Centauri, Betelgeuse, and a bunch more. Those are the ones I can tell you just right now. Let's see. Team trees, yes. How much does a spacesuit weigh? I don't exactly know. I know it's really heavy here on Earth. Let's look this up. How much does a spacesuit weigh? We gotta make sure we're getting a good source. We got to use NASA. So how much does a spacesuit weigh? And that would be, NASA says they weigh 280 pounds on the ground. So I am about 200 pounds. So it's about 1.5 of me is how much I would have to carry around here on Earth. But in space, remember, there's not gravity. So if you jump up, you just kind of float. So you don't have to feel all of that, but it's still more you got to move around. But it's a lot easier. So good question, Wes. Thank you. Oh, thanks, Brandley. You love the show? I appreciate it. Thanks for tuning in. How big is the biggest star and where is it from Glenn? Ooh, so I did make a little diagram for this. So the biggest star ever, or that we know of right now, is UY Scuti. It's a cool little name. But how big is it? It is 1,700 times the size of our sun. What's that look like? If our sun was this dot, can you see this dot? That dot right there was that big. This is how big UY Scuti is. That's a huge, huge star. So where is it? It is towards the center of our Milky Way galaxy. So it's about 9,500 or 9,500 light years away. So if you're traveling at the speed of light, zoom, as fast as it is when you turn the light switch on and that light bulb comes on, for 9,500 years, you would get to UY Scuti, center of the Milky Way galaxy. It's huge. Look, let's bring that in again so you can see the dot. That's the sun. This is just part of the star. I mean, it continues on. It's huge. It goes all the way. It's like the size of a hula hoop compared to that dot. That's so big. Let's see. Biggest star. Where is it? Yup, that was your question. Episode on black holes. We can probably have one of those coming up. Yes. Awesome. Got all the questions. So thank you again for tuning in to A Place Called Space. We'll cover black holes at some point, and make sure you click that thumbs up like button, click subscribe, and keep on learning. Always come back. So keep looking up. Take care.